Okay, so far we've been working with the inverse norm function, and we know we use the inverse norm function if they give you an area, percent, or probability. And we've either worked with it coming from negative infinity or coming from positive infinity. What if it's centered about the mean? And we know a little bit about that because in the empirical rule, it's centered about the mean. Plus or minus 1 standard deviations was centered on the mean. That's about 68% of the data. 95% is plus or minus 2 standard deviation, and this is plus or minus 3 standard deviations at 99.7%. So these were centered on the mean. So we didn't start at negative infinity, we didn't start at positive infinity. So consequently, how do we do that? Now please remember, these are estimates, these are not exact. Use plus or minus 1, plus or minus 2, and plus or minus 3 around it. So we're actually going to figure out the exact value. We're going to use the calculator to figure out the exact value. So we're going to do a lower area and an upper area. The lower area is much easier than the upper area, but in both cases, we're going to need this formula here. So I would star that and this little formula here. So this is going to help you out a lot to have this available to you. So it says, what are the z-scores associated with the middle 68%? So if I'm drawing my picture, I know, and by the way, this says z-score, mean of 0, standard deviation of 1. All z-scores are like that. So we know we're centered on 0, but we want the middle 68%. That means I'm looking for 0.68 here. All right, this area is 0.68, so I need a lower bound and an upper bound. So this is my lower, this is my upper. So I need two values. I need a lower and an upper. All right, so we're going to start off by doing this real quickly. So with this, and by the way, you don't really have to show much work on this. You do have to have the drawing. But beyond that, just make sure you have this formula available to you. So second vars, inverse norm, and my lower bound, my area is going to be, what do we have? Parenthesis, 1 minus 0.68, mean of 0. Oops, I got ahead of myself. 1 minus 0.68, close parenthesis, divided by 2, mean of 0, standard deviation of 1. All right? So when I do that, I end up getting a lower bound of 0.9944. So this value right here is negative 0.9944. Then I need, that's my lower. My upper bound is a little trickier. We're going to go back in there, and I need to add that 0.68 plus 0.68. And now we're on the positive side. And it's like, hey, does that make sense? Let's think about this for just a moment. So we have an upper bound of 0.9944. Lower, negative 0.944. Upper, positive 9944. Well, the lower should be negative because it's below 0. The upper should be above 0 because it's upper should be positive because it's above 0. So here's the way I write this when I'm finally done. Negative 9944, comma, positive 0.9944. And you don't have to use the positive symbol. You do have to add the negative. This is my lower, this is my upper. Two answers, I'm done. Okay? So that wasn't too bad, except it was the first time you did it, and the formula is a little crazy, and I get that. So what are the z-scores associated with the middle 95%? So once again, we're centered. And by the way, they said z-scores, so we know if it's a z-score, mean is 0, standard deviation of 1. Always important to get that information written down somewhere. It's your reference information. So centered on 0, and now I want 95% of the data. So this is going to be 0.95. And I'm looking for this middle 95, and I need a lower bound and I need an upper bound. I need two answers. So here we go. Second vars, inverse norm. And once again, they gave me a percent. They gave me a percent, so I know I need to be working with the inverse norm. If they give you an area of percent or probability, work with inverse norm. And here we go. So we see my formula. So I'm going to go back up here and I'm going to just clear that out. And I'm going to go parenthesis 1 minus 0.95, close parenthesis, divided by 2. There we go. All right, because that's just using that percent. Make sure you put that as a decimal. And we end up with negative 1.599, and I just truncate. So my lower bound is negative 1.955, excuse me, negative 1.599. Now, really be careful about this. Does this make sense? This is negative. Oh, yeah, it's below 0. It definitely needs to be negative. When I go back and I do the upper bound, I just come back and I put a plus 0.95 at the end. And I get 1.9599. So writing my answer, I end up with negative 1.9599 and positive 1.9599. Now, you've noticed on both of these that one's negative and one's positive. But they're otherwise the same number. Why is that? It's because the normal curve is symmetric. And this will only be true that we get the symmetric values if we're centered on 0. So please don't just do that. Please don't just go, oh, I got 1, I'm going to write it down. That's only true if you're working with z-scores. And it's only true because every z-score has a mean of 0. It's not true if we're not centered on 0. And you're going to see that on the next page of notes, that it's not going to be true. So it's true some of the time. It's true if we're working with a mean of 0, which is the case for z-scores, but not necessarily anything else. All right? So what are the z-scores? They say z-scores. So mean equals 0, standard deviation is 1, or the middle 99.7%. Well, we know the middle 99.7% is about plus or minus 3, but as I was indicating to you earlier, they've rounded this. Once again, we're centered at 0. And we're going to be looking for a lower and an upper. And they're telling us this area that we're interested in is 0.997, that area. That's what we want. All right, so what do we get? Second vars, inverse norm. You know what? I'm going to take just a moment and write this formula down so you can see it. The lower is 1 minus the percent divided by 2. The upper is going to be 1 minus the percent divided by 2, plus we have to come back and add the percent at the end. All right, so that way so we're going to have that. Let's put that over here to the side so we can refer to it. Second vars, inverse norm. And we have parenthesis 1 minus 0.997 divided by 2. And we end up getting 2.9677. It's like, yeah, that does kind of round up to 3. So we have a lower bound of negative 2.9677. And the upper bound, second vars, inverse norm, we have the same thing, but we're just going to come back and put the plus 0.997 in there. And we end up with 2.9677. All right. And again, that's not a surprise because we're symmetric about 0 and we're working with the z-score. Finally, what are the z-scores associated with the middle 80%? Lower, upper, 0.80. All right. We know since it's a z-score, mean is 0, standard deviation is 1. All right, to do that problem, once again, we're going to need to be able to use our lower and upper formulas. So parentheses, so second vars, inverse norm, 1 minus 0.8 divided by 2, mean is 0, standard deviation of 1. And we get negative 1.2815. That's our lower. And that makes sense because we need to be below 0, so we should be 0. We should be negative. And then we're going to go second vars, inverse norm, and we're going to add that upper 80%. Please make sure you always use the decimal. And of course, we're centered on 0, so we have symmetric answers here. Okay, so that will conclude centering on 0 with z-scores. We're going to go ahead and work to the serial scenario, and we're going to do the same thing, but actually for the serial scenario, and you're going to see that we don't get exactly nice symmetric answers. We're not going to get a negative 1.28 and a positive 1.28. They're going to be off-center because our mean is not the same. Our mean is not 0. Our mean is 16.2. So that's why it's really important that we know how to use this upper formula, not just the lower. You need to be able to use both. So a packing machine is set to fill a cardboard box with a mean of 16.2 and a standard deviation of 0.1. They tell us this is normal. Remember, we can't use the inverse norm or the normal CDF unless it is. It says 68% of the boxes fall within what interval centered about the mean. All right, they tell us what, and by the way, we're going to use something a little different on the calculator this time. All right, we're going to use something a little different on the calculator this time. So here's what we know, 0.68. And we're looking for the lower and we're looking for the upper. That's what we're looking for, those two values. So second vars, inverse norm. And we know we're using an inverse norm because they gave us a percent. They give you an app, use inverse norm. So second vars, inverse norm, and parenthesis, 1 minus the 0.68 divided by 2. My mean is no longer 0. My mean is 16.2. And my standard deviation is not 1, it happens to be 0.1. And I end up getting 16.1005. That's my lower. Now, my question is, does that make sense? It's like, kind of does. It's below 16.2, and we know the lower is drawn below it, so it should be below it. Now we're going to come back and do second vars, inverse norm, and we're going to add 0.68. When we do that, we end up getting 16.299. Does that make sense? Well, upper is above 16.2, and that value is above 16.2. So 16.2994. All right. We can also do this one other way, and this would be using a stats test z interval. So let's just take a look at that real quick. So we're going to go stat, error test, and then we're going to scroll all the way down to number 7. All right. What was my standard deviation? Oh, it was 0.1. What was my X bar? Well, my mean is 16.2. My N, they didn't tell you how many boxes, so we're going to just use 1. If they don't tell you the sample size, assume 1. And my confidence level is just my area, the centered part. In other words, the center level. And look what happened. 16.101 and 16.299. That's pretty fast, all right? So we can use the second bar, we can use the inverse norm, or we can go to the stats test Z interval. So let's look at this one right here. 95% of the boxes fall within what interval about the mean? Now this interval is going to be a little bit wider than the previous one. So this is 0.95. We're centered at 16.2. We know our standard deviation is 0.1. I'm going to write our mean is 16.2. This is my lower and this is my upper. So this lower bound should be smaller than this. My upper bound should be larger than this because we have a larger center section. We're more spread out. Because remember, this is plus or minus 1. This is plus or minus 2. Because we're working with 1 standard deviation versus 2 standard deviations. So here we go, using my formula. Second vars, inverse norm. Clear that out. Parenthesis, 1 minus 0.95, close parenthesis, divided by 2. And we end up getting a lower bound of 16.0040 and an upper bound. So I'm going to go back to it, second vars inverse norm, and just make you add the 0.95 back. And that's going to be 16.3959. Now some of you are going, hey, can I use that stats test Z interval thing again? Well, let's try it out. Let's see if that works. Stats test. We're dropping down to number 7, Z interval. Standard deviation is 0.1, mean is 16.2. We're dealing with 1 because they didn't give us a sample size. And we're going to change this to 0.95 because we're centered on 0.95. And sure enough, 16.004 and 16.396. Works great. All right. The next one. 99.7. So here we're looking at about plus or minus 3 standard deviations. All right. So we should be a little lower than this one and a little higher than this one. When we're done, let's draw a picture. 16.2. Lower, upper, and this is 0.997. And what we're finding is this area right here. Should probably put those on all of them. They're giving us a percent. If they give you a percent, you're using an inverse norm. All right. So here we go. Second vars, inverse norm, parenthesis, 1 minus 0.997, close parenthesis, divided by 2. 16.2. And we get 15.9. Well, guess what? That is definitely smaller than that. All right. So that's good because we need to be a little bit smaller. So we have 15.9032. And now we need to go do the upper one. So second vars inverse norm. One minus 0.997 divided by 2 plus the 0.997. and we get 16.4967. And this value is above this one. And that's what we said. We thought it'd be further spread out. So let's try that stats test z-test, because that's kind of quick. Stats test z-interval. So number 7. Our standard deviation is 0.1. Our mean is 16.2. If they don't tell you a sample size, you have to use 1. And now our center level, or our confidence level, is 0.997. 15.903, 16.497. That looks pretty good. %, of the cereal boxes fall within what interval centered about the mean? So this is 0.80. Negative infinity, positive infinity, that's not very pretty. Lower, upper. Well, you know what? In this particular instance, this area, this value should be above this one because this isn't as wide. And this one should be below this. So this interval should be a little bit narrower than the one above it. Right, here's our formula. Second vars, inverse norm, clear, parenthesis, 1 minus 0.8, close parenthesis, divided by 2. Mean is 16.2, standard deviation is 0.1. And we get 16.07. So my lower bound in this case is 16.0718. And my upper bound, second vars, inverse norm, I'm just going to come back and add that 0.80. And I get 16.3281. So now let's try using the stat test. Stat test number 7. And we're going to change our standard deviation is still 0.1. Our X bar is 16.2. They didn't tell me a sample size, so I have to use 1. And my center level is 0.80. And I get 16.072 and 16.32. Works out pretty good. Lastly, last problem. 90% of the cereal boxes fall within what interval centered about the mean? So I have a lower and an upper. This is 0.90. This is negative infinity. This is positive infinity. Second vars, and we're doing the inverse norm again. Why? Because they gave us a percent. If they give you an app, you have to use inverse norm. Clear that. Parenthesis 1 minus 0.90, close parenthesis, divided by 2. And I have 16.0355. Stat test, second vars, inverse norm. And we need to find the upper one, which means I need to come back and add the percent. Plus 0.9. Oops. So we'll go ahead and do it plus 0.90. 0.90. And I get 16.3644. All right, so lastly, we'll do it the quick way. Stat test number 7. which is Z interval. Standard deviation is 0.1, mean is 16.2. They didn't tell me the sample size, so I used 1. And we want it centered about, we want 90%, so centered at 0.90. 16.0, oops, sorry about that. Let me bring that back up. 16.036, and then 16.364. All right, so that is our serial centered about the mean. Thank you.